Yo, yo, yo. What's up, everybody? Welcome back. Today, I want to try turning a measuring cup into a light switch. This little guy. I want to use him as a light switch. Turn the lights on, you know? Um, and you, the context here is a little bit confusing. But well, I promise there is a reason. There's a good reason. So, I'm working on this Xbox controller. I'm trying to kind of make one from scratch. We've got, some sort of like hardware model. I've 3D printed it. We've done a few iterations on this thing. It feels like okay in my hand. We have, a PCB that we've like almost finished. We're not quite there, but we're kind of getting the part layout and the wiring kind of figured out. And the idea here is we are copying, if you Google open source controller, you find this guy. And this guy has done a lot of the work for us in terms of like figuring out how to put things together. But we are kind of copying his approach of just kind of soldering a Raspberry Pi Pico onto a PCB and using that to do all of the heavy lifting in terms of like firmware stuff. So we're gonna just like program this guy. He's gonna forward buttons onto our computer, etc., etc. So these guys have gyros on their board. And I was going to skip gyros, but somebody in my chat, asked like twice if I'm going to add them. And the first time I was like, God, no. The second time I was like, God, no. But then I've started like watching videos of people playing Counter-Strike on controller with gyro aim. And it actually looks like kind of fucking sick. I bought a PlayStation controller yesterday to kind of like test it out, see how it works. And I will say, like, gyro aiming is like surprisingly competitive with mouse and keyboard. Like, I'm not like at the same level as mouse yet, but after like a day, I'm pretty damn close. So it's kind of sick. I'm kind of sold on the idea of gyros. So I was playing around with the gyros yesterday, and I kind of found that something that I do often, which is kind of probably abnormal, is I will press the D-pad on my controller, which is like here, with this hand. So I'll actually wrap this hand all the way over and do this. And then I will also sometimes, I don't know why, I'll hold the left stick forward with my right thumb. I'll wrap all the way around and hold this forward and like scratch my face or something, stretch my hand a little, and then put it back. Why don't I just do it with my left hand and scratch my right face with my right hand? I don't know. I'm not God. I'm not omniscient. Fuck off. You just stop putting so much pressure on me. I don't know. But anyways, when you do those things, it turns out that you move the controller a lot. And if you're using the gyros in the controller to aim, it means that your aim will get all fucked up and you won't be running in the straight line that you wanted to be running in, right? And so, all of that is to say, I want some way to automatically detect when I like want to be kind of using my controller like this to aim like a fucking idiot, and when I don't. And so, my thought here is that if I go onto the back of my controller and I put a little bit of like a capacitive sensor right here where my pinky goes, when my right hand is like wrapping off of the stick, he won't really notice that anymore, right? Like if I say my finger has to be resting here for the gyro to be on, that would be fucking cool. So what we need is some way to do that, right? We could put a button there, but then holding the button all the time would kind of suck, right? Like a little dead man switch or whatever. So what I would rather do is have some sort of like capacitive button. And so I was kind of looking up like how the fuck does that work? And so back to the Input Labs Alpaca, the controller we're copying. These guys, they have gyros in here as well, and they've actually kind of got a setup where they don't really use the right stick at all. I'm not going to do that, but similar. And what they do is they say if your thumb is resting on this hexagonal plate right here, gyro is on, and if you take your thumb off, gyro is off. So like, what the fuck is this? Well, it turns out that if you take a bunch of like carbon dust and you just like mix it into your 3D printed filament, you get like an electrically conductive surface here, which is kind of sick, right? This guy, when you touch him, your body like makes electronic connections with the inside of your board. And so then the question is like, okay, so what the fuck is inside the board? And so we pop open their schematics, maybe this one. And if you zoom in to like where that thing connects, it kind of like just rests on this pad. And you look at this, you're like, wait, that's not like a chip. That's just like some like metal connections on the board. And if you look at like where these things go, it's actually quite a simple circuit. They just have one GPIO, GPIO 6, plugged into a resistor. Then the pad the pad just connects here into another GPIO. So like, how the fuck does that measure if like I'm pressing a button? Well, it turns out that your thumb pressing this thing kind of makes like a really big capacitor. I like really didn't understand this yesterday, and I still don't really understand it, but I understand it a little bit better. So if I was like Googling this and I found this picture, I was Googling like make capacitive touch sensor, right? But this picture kind of like explains it, right? So this is like, I'm not sure how many of these like capacitors in here are like real / fake. But basically there's like the real Earth, right? The planet that we're all sitting on. And we like it when our electricity goes into the ground of the Earth, right? This is different theoretically than the ground of like your controller, right? Because if your controller is wireless, then like it might just be using like some reference to that isn't the same as the planet, right? But like through like the air and shit, it's kind of like linked to the planet in some way, right? Maybe not like super strongly, but there's some sort of like molecules can go through the air and get to the ground, I think. Please, any electrical engineers, feel free to leave in the comments how fucking stupid I am, right? So if you just like put like a hunk of metal here and you touch it, your finger kind of like makes a capacitor with the metal shit you're touching, right? You're making like you're creating like a surface for electricity to flow through in some way, right? And you can kind of like approximate your body's connection to Earth as like another capacitor and a resistor. Doesn't really matter, right? All I really need to understand here is that like we're completing some like big circuit with the world and your controller. And by doing this, you're like changing the capacitance of whatever this surface is. And by doing that, you're like holding charge like in your fingers. I think. So like back to this picture, if you take GPIO 6, probably 6, maybe 7, I don't know. You take GPIO 6, you set them high. You say, let's go 3 volts. Your finger will like store some like electricity in it. It'll be like, yum, 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 tasty, 3 volts, right? Then you flip the GPIO 6 back to 0, and it doesn't immediately get read at GPIO 7 as 0 anymore, because there's like some like tasty electricity in your fingers, right? And so your fingers going like, let me feed GPIO 7 a little bit. GPIO 7, like, this is supposed to be ground. Let's like let all the electrons out of my fingers back into the floor, right? Hand wavy, I think. And the time it takes for GPIO 7 here to read the change from GPIO 6, I think is supposed to change if I'm touching the thing or not, right? I think. And so my understanding of this is that I just need like a metal surface to like make a capacitor with my hand with. My understanding from like reading like these bullets like is that the size of this sensor matters, right? And also like how fucking fat I am. These fucking assholes are calling me a fat piece of shit. They're like, you know, you might be 100 picofarads, but you might be 200 picofarads. You fat fuck. That's right. That's what they're saying. But yeah, so my understanding here is that like if I just make like a, you know, large surface contact with some hunk of metal, that I should be able to basically replicate what they're doing here as like measure how long change take. If take long time, button press, right? That's kind of like my understanding of it at this point. And so obviously you can tell I don't really know what the fuck I'm talking about. But you know, as we do on this channel, we'll try something, and hopefully by falling over a bunch of times, we'll understand a little better. So what I want to do is I want to do something that's basically the same thing as this, right? So I have on my desk, I have connected the Raspberry Pi Pico. I've got 2 pins that already had wires coming out of them. So I'm just reusing, I think it's like GPIO like 16 and 19 or something. Raspberry Pi Pico Pinot. Fuck. I just want the picture. Hello? So I'm using GPIO 16 and 19. Wow, that was a good guess. So this is 1916. This is connected through a 1 mega ohm resistor, I think. I copied what they did. I'll have to double check that. And then just back, right? And then in here, I've just got like a wire sticking out. Boom. So what we should be able to do is like attach the measuring cup, this like metal measuring cup here, to just like touch this together, and then I should be able to just like stick my finger on here. That's a finger, right? And that should do something, right? So the plan of action is to first just set up like the GPIO test at all, right? Right, like if we're trying to measure the time it takes for GPIO 19 to notice the change in GPIO 16, that means 16 has to be configured as output, 19 has to be configured as an input, and we have to be like toggling 16 at some rate. Then once we get that set up, then we can like figure out how to time it. And then once we figure out how to time it, then we can like connect everything together, see if we see a difference when I touch it. Sound good? Sound good. That's the plan. And if all goes well, it'll just kind of work. But things probably won't all go well. Nice finger XD. Okay, chill. Chill. Sparavoria, do you ever find yourself reading books, watching courses, or stuff like that in order to learn a topic? Or do you just dive into what you want, then search online for answers? I'm definitely more of a start something and then Google after type of guy. But it also means that like my understanding of stuff is very incomplete a lot of times. I do watch like educational content, I guess is what you could call it, on YouTube a lot, but it's kind of more just like slop that the algorithm feeds me, right? Like I don't really know how do I say this? I don't find that like listening or watching or reading things really like solidifies knowledge. It more is like a way to be aware of broad topics. I find, right? So like I think that it's really easy to watch something and then think you understand it, and then like a week later have no idea what the fuck any of it meant. So I find that for me, doing is like the best answer. Now, of course, here we're going to end up with a very poor understanding of electronics, right? I don't think we're going to understand this at all, but we will understand like how to make it work if it works, right? Which is, I think, a relatively big win. All right, let's fucking get into it. So we in our current Raspberry Pi Pico firmware have just like a lot of shit just kind of happening. We've kind of been like stacking experiments. We have to make sure to stop the experiment of using we had like an ADC connected to the SPI bus, and we're reusing the SPI pins. So I think we just have to make sure that wherever we're doing SPI, we just don't do that. So let's turn this init SPI off, and then let's turn back on the code that was spamming hello and toggling the LED on board. And let's see if we run that. That's like kind of like a reasonably good starting point here. Okay, so let's get a serial console hooked up. Let's make sure everything's plugged in right. Give it a sec. He's thinking. Picocom. Okay, good. So we're spamming some hello 8, hello 9. Chill. How do I get out of this thing? Like that. Okay, cool. And then if we look, I don't know if you guys can see this, but that LED is slowly blinking on and off in the corner. On, off. On, off. So that's good. That's good. We're chilling. We are so chilling. I don't like it that high. There we go. Is that a little better? I don't want to be like, I want to look tall, but not like a fucking giant, you know? I need to trick you guys into thinking that I'm not short as fuck. You guys can't tell. You only ever see me sitting. Okay, so that's like a good starting point. Let's try to figure out how to like initialize GPIOs 1619. Oh, we also have init I2C, which was also using the same fucking pins, which is commented out. Okay, cool. Cool. So let's do we'll call this capacitive touch experiment. And what are we gonna do? We're gonna take GPIO like output pin is 16 and input pin is 19. Output input, yeah, sure. And we're gonna have to configure output as output. So how do we do that? Whereas like when we init LED, init GPIO output, we have a function for that. Look at us go. Look at us writing functions and shit. Init GPIO. Oh, we have init GPIO input. We're kind of fucking killing it. So this is just 16 and 0 probably should be his initial value, and init GPIO input is going to be 19. We should use the names. Okay. And I guess let's read the input. So this guy says, I want pull up. I guess we should probably decide whether we want pull up or pull down. It probably doesn't matter that much, but we might have to think about this a little bit. But otherwise, he should be good to go. So can we just read the value? Maybe we'll do like 4, 0 to 5. Let's do something like toggle the output. Let's just set like, how do we set the LED value? Do we just like, okay, we just have like a GPIO set register somewhere that we write to, and that should do something. So it should be like GPIO set, yes, one output pin, right? So we'll turn them on, and then we will read it. GPIO in, I guess. So I guess we like check. Is this really, do we not have like a read this thing? I like this way of doing it more. Pipe. We have done this before. So it's like, take this thing, shift it right by input pin, and then truncate it. And this will tell us the value like this. And then I guess if we're trying to time this thing, we could just like hot loop here, or probably the correct answer is setting a time stamp and waiting for like an interrupt value is probably the correct thing. So maybe we should do like while something. I wonder how that guide would rate the physique of a metal pan. If we run into problems, it might be because the pan's capacity to soak up excess charge. Yeah, this could be. I agree. I don't know. I've not done this stuff. Many chatters seem to be more knowledgeable. Yeah, I agree. But we'll see. Okay. So I guess let's just toggle this thing on and off a few times. Var enable is false. And then we'll do like if enable, we set the output, else we clear it. Right? We do something like this. Then we say enable is equal to not enable. And then let's print the output value. So std log debug, and we'll say read value of this. We'll do the timing shit after. Let's just start here. Okay. And then is there anything else we gotta do here? No, I guess we have to call this function. So after we UART in it, we'll do this experiment. Probably after the LED is initialized as well. Okay. Okay, so he's in the hello section again. Restart. Red value of 1. Oh, we didn't, we should probably sleep for some amount here. So we should be doing like, do wait for 1 in nanoseconds. So 1E9 would be 1 second. Maybe we can go way shorter. Maybe like 10 milliseconds. So this seems bad. He's reading value of 1 every time, which might mean that I don't have this thing hooked up right. That's very possible. It also might mean that this stuff is not working. So I think it's time to bust out the scope and just like check if that value is being set at all. So give me 1 sec. Let me plug some wires in. Oh my god, I can't fucking see. Depth perception, fucking hard. And then also, just so that you guys can see it, let's take a little screenshot of this. Can we make it bigger? How do I see my own stream big? Here we go. Let's just do that. Flip this back up. Okay, so that you guys, hello? No, I can't fucking, I fucking just screenshotted. Do I really have to do that again? Because it's not fucking pasting. I hate my life. Did it save somewhere? Dolphin. Like if I go pictures, screenshots, no. Just get fucked me, I guess. Get fucked me. I guess we will go again. I guess we need to transition. Full cam. Go big full screen. And then screenshot. Please God. Save. Okay. There we go. Is that better? Maybe. Maybe. I'm sure there's a better way to get this information as well, but you know. Shut up. So this, let's can I want this in paint. Open with color paint. So like the circuit is what color won't conflict? It's 1M ohm. This is 16, this is 19, this is output, and then what you're, this is like, this is the resistor here. Then things are going like over this way and then back. And then this is our test point. What's the measuring cup for? For a metal contact. For a metal contact. We need something to touch, but we'll get there later. This isn't part of the scenario yet. Okay. So what I want to do is I want to pull out my scope, I guess, and just see like when these guys are getting toggled, do we see anything interesting? Which I guess means you guys, instead of just staring at this picture, probably want to see me plugging stuff in. I guess that's the most interesting thing to show while we do this. Look at my dirty ass desk. So I guess this guy, one end needs to go to ground. I think that's ground. And then I think this should see the change in and out, or the GPIO 16. So if everything's set up right, I should turn on the scope. And I should see that if I guess let's just do this forever. We'll change this to a while true. We're hoping to see like the scope just start freaking out. Which, good news, we are seeing. Hold on, how do I zoom out here? Okay, transition. I mean, at the very least, you can see he's spazzing the fuck out. which means that the GPIO is properly being set, probably. Right? So that's kind of hype. I would like to change the scale of this. How do I make it fast? One of these buttons should change it. I just don't know which one. Oh, I think I found it. Yeah. I found it. Oh yeah, look at that. Look at that beautiful fucking. Oh yeah, that's a fucking up and down if I've ever seen an up and down. What scope is that? It's a, I don't know, just like I googled on Amazon oscilloscope and picked the cheapest one. Okay. So that's chill. I guess then the question is why are we spamming read value of 1? I guess we didn't check that on the other side we're seeing the same thing. So I guess we move the probe wire from one side of the equation to the other. And we see if the scope is still saying anything. And now he's not. So I guess that makes sense. Fucking beautiful energy drink, missing keyboard key, 3D printed stuff, breadboard, scope, random household metal objects. Yeah. What does your guys' desk look like? You being angry with the key and rip it off? It actually just broke. It just fully broke. I think I was spamming that key a little too hard. Oh, actually, that key, we'll show it. So the missing key here is actually not the broken one. This is the key that broke over here, and I needed a key for K, so I just took one off page down and put it over here. It's the ultimate fix. They're all the same. I don't need a page up or a page down key. That's confusing. Oh, I took page down off the page down spot because it's the right height, then moved insert from the insert spot to page down. Of course. Okay, so I guess you could assume that we're probably doing something fucking stupid, right? I think what's happening is we have GPIO 16 goes to 1 mega ohm resistor, which goes into 17, right? But like what's in 17 is actually a pull-up resistor of unknown size to 3 volts. Right? So probably what's happening here is this guy's so fucking big that like this is eating the change in the change, maybe? I'd be interested to see what happens if we turn that pull up enable here on the input pin. Can we say like enable pull up? I guess we'll say like pull up as a U1 and pull down as U1. That's the easiest thing to do here. Let me put like PU and PD here. Then whoever calls this has to say what he wants. So probably 1, 0 is everybody who's called this thing before. To match. Okay. Unable to resolve comp time value. True. So we'll just huck some comp times on here. Okay. Hype. That fixes everything. And then, so now if we switch this to a pull down, whichever one of these fuckers it is, I'm assuming that the scope will start saying low instead of high. Yeah, so here we're seeing red value of 0 spam now, and the scope, I'm not going to show the scope, but the scope is showing 0 as well. So that lines up. So that means that the GPIO input is probably working, and it's more that using the pull-ups and pull-downs is fucking us. So can we just turn them both off? If we turn them both off, what happens? Oh, hype. Here we go. Look, 1, 0, 1, 0, 1, 0, 1, 0, right? So presumably this guy was the mistake, because like the other option is this, right? We can kind of do one or the other. Hi, bro. Do you think AI will replace programmers? There are a lot of layoffs right now. Jensen Huang, Elon Musk, and Sam Altman all think they'll happen in 2 years. What do you think? Dude, this somebody copy pasting that is really funny. Yeah, that's a good copy paste. Okay, no. Let's just no. I think that like all of these people are heavily financially motivated to say that. Have you ever like every time I fucking use AI, it's shocking how shit it is. Like absolutely fucking shocking. And even if it was pretty good at programming, it's like if you've ever worked any programming job, the whole job is like trying to figure out what the fuck people want. Right? It's like I think that the reason we have code is because saying in words what you want is not precise enough, right? So you say it in code to get like exact definitions. It's like do we really want like lawyer speak for computers? We already have that. It's code. So like I don't know, man. My read on everything AI related is that it's an generally overhyped. There are obviously places where it like is very useful. Like image recognition is like a very real thing that is useful and works well. But like this like LLM generic general AI shit is like it's so far. It's so garbage. How's the dog? I hope it's all right. Yeah, I took her to the vet this morning and they said she's fine. So I'm not really too worried about it. But yeah, she seems to be doing better. Thanks for asking. Okay. So looks like we're chilling. We have a guy that toggles back and forth, and I guess the question now becomes, what is the time delay that we see between those things? We have to find some way to measure that precisely. So I think the ideal situation here is we could pull this thing in a loop. That's one option. But I think probably an interrupt handler feels like it's better, right? Instead of sitting there like that way when the interrupt handler is triggered, we know exactly like it should happen like boom, right fucking now, right? So we need to set that up. I think that we have set up interrupts before somewhere in this pile of shit. So I think that the bigger thing we need to do is configure something to trigger on and we've done that before. Proc interrupt enable, GPIO to edge low. This seems a lot like what we want. So here we probably just want to say, hey, on GPIO 19 transition, let's fire an interrupt, which will probably come from this data sheet somewhere. So we're looking for something along the lines of this address, IOBank, and we're trying to look for the registers in here. So he's got some interrupt registers. We're looking at interrupt enable. So which one of these is responsible for pins 16 and 19? Looks like inti2 lets us configure. I guess we only care about 19. So here we should just be saying let's get an interrupt when this guy goes low. And that should just work. So this is proc 0 interrupt enable 2, GPIO 19 edge low. Proc 0 interrupt enable 2 is not defined. So looks like we need to define some types. So probably it's like all of these guys need to be defined like this. And they need their addresses defined correctly. So it's offset 8. So probably the back register changes here to 8 on each one. Just got my first electronic starter kit in the mail yesterday. What microcontroller is on your breadboard? It's a Raspberry Pi Pico. Raspberry Pi Pico. Okay, so we have set up this like JSON to Zig code generator thing. So we kind of like copy paste some definitions of pins from the datasheet, and that turns into like some code with nice functions that lets us like make sure we're only doing 32-bit writes and we're masking off the little things that we care about, and like but like with nice names and stuff. So we should be able to be like interrupt mask 2, and we just have to copy paste these definitions. So it's gonna look something like this. Inty2. We just copy paste this table. Do some Vim magic. I also will say, if you've got your shit in the mail, you're probably going to be doing something that's a lot more reasonable than what we're doing. They have like a nice SDK that we're like intentionally sidestepping because we're a little nuts. We hate ourselves, but you know, it's kind of fun in some way. So paste this here, put a colon, lowercase, and quotes, put a comma, go. I fucked that up. Record a macro, word, delete to the end of the line, go back, word, delete to the end of the line, go back, paste, colon, comma, oops, lowercase, quote. There's a good kid, so I fucked that up, but he seems okay. So we spam that a little bit. And then we copy paste this back into the JSON. And then what should happen is we should get a struct generated with the name of GPIO interrupt mask 2, and he should have everything set that we want. So if I hit build now, everybody's happy. Any plans for after the controller? Maybe because of the keyboard? I don't know. Yeah, no real plans. I shouldn't say try. There's no point in me planning that far ahead because I will change my, like, generally what happens is I will see something somewhere that triggers a thought, and then that thought will like consume me. So I just kind of like trust that will happen. And I actually have to intentionally try not to let that happen while I'm trying to focus on something because it's easy to let it get out of control. All right. So now I think that we should hit an interrupt now. That's good. We have like an interrupts file set up in an interrupt table. We're hitting interrupt 29, which I believe should be the interrupt for GPIO. Can we look up like IRQ maybe in this? Here we go. So we're seeing interrupt 29, which is offset by, I think, 16. Let's see if that 16 is the number I remember. So if we're seeing a GPIO interrupt, 13 plus 16 is 29. So that's right. Okay. So we're seeing an interrupt on this guy. And so what we have to do is replace that do nothing function with the correct thing, right? So we should be like, in our interrupt vector table at 29, we should be like, let's do GPIO handler. Okay? And I guess let's say here, I don't know if we're supposed to take in any arguments here. Looks like probably not. So here we should just be able to be like, I think we have to like clear the interrupt to stop it from refiring, I believe. But first let's just make sure that this gets called. So if I breakpoint in here, we should get a breakpoint in GPIO handler. Very good for us. And if we just do nothing, I think that we should proceed now, no breakpoints, but we're probably like spamming that GPIO handler because he's not clearing the interrupts. So probably, let's see, IO bank 0. I don't really know if we're supposed to clear it on the GPIO side or on the interrupt handler, like the interrupt thing. If I remember correctly, it's like you have some chip on the board that's like doing GPIO shit, and one of his outputs is like interrupt, right? And that goes into, I think they call it NVIC, something interrupt controller. And then this goes to like ARM processor. And so like, I don't really know. I think that there's like maskable interrupts. So I think here you can like be like ignore interrupts on some pins. And then here, maybe we're supposed to say, okay, we've handled the interrupt, I think. I don't really remember. So let's just look at IO bank 0, which is, I believe, hello, IO bank. Maybe we search for this address again. Okay. So we have interrupt status after masking, and then we have interrupt enable and interrupt force. Is there like an interrupt example? Probably, right? They probably have an interrupt example somewhere in their examples. GPIO IRQ type. Okay. So in their callback, oh, it's probably auto fucking acknowledging in the SDK. That's annoying. So what's this thing called? GPIO callback. Do they set this GPIO set IRQ enabled with callback is where this is going. So it's probably somewhere in like the SDK. Somewhere in here, they've got like GPIO.c probably and set IRQ enabled. Yeah, they have GPIO acknowledge IRQ. This is what I'm looking for. So they say, let me set the interrupt field on this guy to. So they're acknowledging some events, okay, that are shifted left by some amount. Sure, they're doing some like clever shit, but it's what they're really doing is they're writing to the interrupt field here. So that's probably enter here, raw interrupts, right? So probably here you have right to clear on these guys. So we probably just need to go into enter2 and clear that shit. Clear that shit. So we have interrupt enable. We do need the proc 0 enter. And this is going to be enter2 at OF8. Okay. So this is enter2. Okay. Oh, we actually have enter0. So we should just, we'll keep the names. We'll keep the names consistent. And so in the GPIO handler, this is actually not, yeah, this is. We will acknowledge enter2. And here we will do a... Why? Oh, autocomplete doesn't work because we generate a file that the language server didn't know about, so we just restart. So we'll do a modification of this thing, and we'll just write out GPIO 19 edge low with a 1. And that should clear the fucker. Okay, so I think let's try to get a test that makes sure that this works. So if we only set this thing one time, okay, we do this one time, we should end up in a scenario where the interrupt just like fires forever. Right, so I would put a breakpoint in here. I believe, since the interrupt is never cleared, we're just like spamming this interrupt handler, right? But if we acknowledge the interrupt, then we should only see this breakpoint one time. Good, good. That's huge for us. Huge for us. So now this thing will only trigger when the guy actually transitions to the low state. And so if we say do this like once per second, right? Toggle once per second, we should see that breakpoint trigger every 2 seconds if the breakpoint is still in there. I actually think I left it. I think I left the breakpoint out. So we should see this trigger every 2 seconds-ish. We see it twice. See, let's continue. Twice. Yeah, okay. It's interesting to me that we're seeing it double trigger, because we should only be seeing edge low transitions, so that's a little strange to me. So maybe there's like some slight instability there. But fuck it. Fuck it. Okay. So now we need to like figure out how long that took, I guess. Which I guess means like counting ticks of some clock. Probably. I'd be interested to know what the alpaca firmware does here. Let's take a little peek. Do we have maybe their firmware here? Then in source, they got touch.c, and how do they do this? Touch get elapsed. Okay. So they start a timer, or they get like the current time as a US32. Then they write this down again. Then, oh, they just do it inline. So they don't do this interrupt shit. But I mean, they just have a function time US32 is really the key here. And so what does that do? Is that defined in this? I don't know. Let's, maybe it's fine. Maybe we should clone this. Maybe we already have, actually. That wouldn't shock me if we had this already somewhere. No, okay. Time US 32. Oh, is this a Raspberry Pi Pico SDK defined function? Probably, huh? Is that in... Time US 32. Ah, it is. Okay, so how does this thing work? Probably... timer.c. Time US... hello? Timer US 64 just reads values from the timer bits. But like, I thought that this thing didn't have enough resolution to do anything reasonable, but maybe I'm just misremembering. So let's look at the datasheet and see, look at the timer section again. Did I lose it? Here. Timer. So their counter has a 64-bit counter that changes at the microsecond level. So I guess that is totally fucking fine. Because I seem to remember this thing ticks at 1 microsecond. Because this is attached to the watchdog, I think. So do we have any code right now that reads that? So, like, where does this guy live? I remember looking at this at some point and, like, maybe, like, do wait. No, we're just looking at ticks. I remember having trouble with the fact that we had to read these in a specific order. This sounds, like, really familiar. So can we look for this address? Is this in our codebases all? I guess not. All right. All right. Fuck it. I definitely did something with this. We probably lost it when we turned on the crystal. I think that what happened was we were using the like default oscillator and using that as a timer, and then we started counting clock ticks of the X oscillator and like the crystal X oscillator instead, and we probably lost it, which is fine. This isn't that hard. So let's just yeah, there's no like timer in here or anything. Yeah. You may still have the register defs. Oh, true. This might have been before the register thing though as well. Yeah, I don't see any time in here. Okay, fuck it. This should be easy. So we have timer base at this guy, and I guess the things we want to read are, I don't know why in the SDK they're reading raw values versus there's like time HR, time LR here, and then time raw here. I don't know what the difference is. It just says raw read, no side effects here. And then what about here? read from bits. So maybe the side effects here are that we like latch something. I don't know, fuck it. I'm just gonna read time LR and time HR. You can't stop me. So this is probably like a volatile U32 from base plus OC. And then this is at 08 for HR. And they're saying always read LR before HR. So read time here is going to return a U64. And it's going to be like var ret is U64 is the lower half. And then upper is time HR. And then return. Can we do this like this? Return upper, shift left by 32, or lower. Like this. That seems fine. And this read time US, I guess, for microseconds. Okay, so we should be able to be like, where is our little experiment? Capacitive touch experiment here. So we should be able to be like, timer read time US start, and then here I guess we do like while waiting, while, yeah, we need like some global that we register somewhere, but for now we'll just be like var end time is equal to 0 or something, or like yeah, GPIO edge low time. So can we do like while GPIO edge low time equals 0? I don't know what the zig rules are here. Like if he understands interrupts or not. I hope so. I hope I don't have to worry about this. We should just be able to do this, and then GPIO edge low time, then do like log debug took this many microseconds, right? Something like this. Something like this. Yeah. Sure. So then, can we, in the GPIO handler, where the fuck that is, we should organize this a little better, huh? But, get fucked. You know, can we do something like that? 138, he's mad because we need to pointer from int here. Boom. All right. That's not good. Okay, so let's, we need to bisect. Oh. If we are waiting forever and we don't start with an edge low transition, then that's a problem. So while enable and here, or is it not enable here? We're clearing. So if we clear this, then it's this way. Let's try that. Oh. Other way? Okay. Cool. So that breakpoint is being hit, and then does he say here? What is do nothing 3? Probably probably like the timer, some like timer expiry or something is getting triggered now that we were talking to the timer. Do nothing 3? That sounds like a internal interrupt firing. That's interesting. Sounds like it. Yeah, can we look at the interrupt table or something? So these are off by 16. What are like the this is gonna be like in like the ARM processor section of this guy. Probably he's gonna tell us about the interrupt controller. Probably. Where have I seen this before? Maybe I saw it in like the Cortex M0 Plus reference manual or something. That sounds familiar. Then like interrupt controller here. Do they talk about God, it's so I'm struggling to remember where I've seen this before. Like I seem to remember there being an interrupt table in this thing. Like maybe I saw like systic. Like this we discovered somehow. Is this even the right doc? This feels like kind of too high level. Oh, maybe it was in the ARM v6m manual. Yeah, here we go. Here we go, baby. And then somewhere in here we had like interrupts. Here. I just want to know what interrupt 3 means. Please, God. Exception model sounds familiar. Here we go. Hard fault. Hard fault. What is the hard fault? We're just writing to something that doesn't exist? Oh! Oh, this is fun. We've never had a global variable before. Haha! Okay. We're fucking we're going down the rabbit hole. Global variables. Okay. So, the way that our program is set up. Hold on. I need to quickly refresh my memory. So, we're loading from cache. Beep boop, beep boop, beep boop. If I remember correctly, there is like Zig, when it compiles stuff, is creating us a Linux executable file, elf, right? And in the elf file, he stores different types of data in different segments, right? So if we look at like read elf segments on this, read elf -s, here we go. So in here we have like different chunks of stuff, right? So we have like text. Text is like the code. We have RO data, constants, BSS, like global read writable storage, right? And we need to define where this stuff lives in like the memory of our program. And so I think what's happening here is when we start up, the processor will just start executing code from some address, right? So you have like the processor, the ARM processor, right? And he's like connected to like memory bus. mem bus, which isn't just memory, but this is kind of like you read and write from this bus, and like stuff comes. Some of that stuff is handled by like RAM, some of it's handled by like flash, and some of it's handled by like hardware, like mapped registers, right? So like the GPIO controller is like on this bus, right? And so he's going to start executing at some fixed address on here that's in like read only memory, which has a bootloader boot stage 1, if I remember correctly. This guy's kind of configured to check if you have a valid program at a specific address in flash. I think it looks at the last little bit of flash here. And in here, we've written like a program that's, I think, is like max 256 bytes that basically configures the rest of the program to run. And so in here, we are supposed to say, hey, this elf file that Zig compiled, he's expecting this data, this readable storage, to be at this address. And it's possible that we just haven't configured that. That's like a very real possibility. I would love to see in the debugger if we can prove that. Because I don't think that we ever intentionally set up BSS. That's like a thing that we have to do in our program. So, okay. Oh, actually, I'm just a dumbass. We're actually getting an integer overflow. So I do want to know, actually, this could be related. It could be. So can we go to like frame 3? Frame 3. Frame 4 maybe? GPIO edge load time. Okay. That's great. Let's start here with printing both of these guys. So he's getting 0. Oh, I'm just a dumbass. This has nothing to do with this. So it could be that the initial value of GPIO edge load time is not configured correctly. I don't think that we set this up right, but we're actually seeing a different bug here. I just got sidetracked. So if this, then we do this. Or we just do a saturating sub here, and that solves the problem. All right, let's try that. Okay. Okay. This is something. So we can see that it takes longer for him to go from 0 to 1 than 1 to 0, I think. So here he's like almost immediate to go 1 to 0, and then he's taking some time to go 0 to 1. Now, the question is if I just like take this fucking wire and I touch this metal cup with it, right? Let's can you guys kind of see that in the corner? It's like kind of small, but it's okay. So I just like touch this here. Why'd everything stop? What the fuck? Okay, hold on. So, did I like pull some wire that I wasn't supposed to by mistake? Because what was happening before? I had this plugged into the oscilloscope, and everything was kind of working fine. Oh, that's interesting. And then if I unplug this from the scope, does it break? Yeah, where is he stuck? What am I confused about here? While I guess this should just be like time capped. So while I am turning this thing on, isn't this inverted? No. If this is like the equivalent of if not enable, then we wait for this thing. That's what this is doing, and I just have to write it this way because I'm too stupid to understand it the other way. Okay, and so now this interrupt is just not firing when this thing is floating. So why does me leaving this pin floating change the behavior of this circuit? That's surprising to me. Let's bring the pull down back. Because I guess technically he is supposed to be zero, like... Interesting. Okay, let's... Okay, so... Now he's reading 0 all the time because he's pulled down, right? So we intentionally turned off the pull down before to fix that. Thinking that, like, the pull down was dominating. So now he is flipping 1 0 1 0, right? That's great. So then why does the interrupt stop firing? Right? Like, what the fuck? It can never discharge without load. Okay, so the circuit should be, at this point, the circuit should be GPIO 16 resistor GPIO 19. Am I stupid for thinking that I should be able to read this value without pulling it one way or the other? Am I stupid for thinking that? Is that just not how it works? It might be. But I don't understand why. Like, I would think that... Yeah, And then also, we are seeing the value change. It's just the interrupt's not firing. That's the weird part. That's the part that's weird for me. So can we breakpoint here? And see if we can understand, like... So that's hit. And then he's hit again? I think maybe the logs are confusing us. Wait, okay, hold on. GPIO edge load time. No symbol. I guess maybe just sometimes it's not triggering for some reason. Can we just... Let's just add a timeout here. If now minus start is greater than, 1 millisecond, break. I guess we'll just do this for now. Okay, here we go. So this is now basically immediately firing. And then if I connect the scope back again. Okay, that's changing stuff. Okay, so now if I just like tap the metal with this thing, we're seeing one millisecond, and then I hold my finger on this thing. 5 microseconds, 3 microseconds, 4 microseconds. Dude, that's not very... I mean, that we are seeing a change, but it is so fucking small. What if I put like my whole hand on it? 4, 2... I mean, that's sketch as fuck. I mean, I think that we are seeing a change, but it's just so unreliable. So I'm curious. I guess we can kind of say this is done. And we're kind of looking at fill it with water. Yeah, I guess that would do something. Okay, let's change this. Let's say that we are why are the numbers so small? So it could be that we're kind of that the interrupt method is kind of fucking stupid. Right? It could be that the interrupt itself is taking some time out of this thing. So I'd be kind of curious to try just like spam polling. But even then, it's just like 5 microseconds is like really low res. More timing resolution might be nice. Yeah, but like why do they not have this problem in the Alpaca firmware? Right? Because I feel like I copied their circuit a little bit. I mean, maybe like the material and surface matter, right? It could be that I'm a dumbass and don't understand how this works. But like, what is their like touch timeout defined as? Oh, we have this checked out somewhere, right? We can just search for this. Alpaca. Touch timeout. So they time out after 100 microseconds. Oh, wait, we were seeing it fire twice, right? Earlier? Right? Am I remembering that right? Okay, let's do this. If we were seeing it twice before, then it could be that the second one is the one that we want to look at. Maybe. And if that's the case, we could try just changing this guy to always time out after 1 millisecond. And just like take this while loop out of the, like change this to a while true or. So now we'll always wait the full 1 millisecond, and maybe we'll see kind of like a bigger value now. Okay, took 1 microsecond, took 1 microsecond, took 1 microsecond. Now hold my finger on it. No. This is kind of behaving the same. I mean, it is a measurable difference. I would love to see what values they use. So let's take a look here. So touch status, threshold. Ooh, they're using like a ratio of like 1 to the other. Touch auto ratio, wired preset 1. Which is only like 2. So if this is the ratio of like on to off, then maybe we're easily within that. Right? So they're saying um if smooth is greater than the threshold, then it is touched. Smooth is elapsed and elapsed previous, and this is a multi-sample here. Okay. Wait, so it's if the smooth thing is greater than the threshold, where the threshold is like 2. Right? And so they're literally just getting like. Is that what we're seeing? Get threshold ratio. Ratio feels like the wrong word. So take as many samples as possible within the available time. They get elapsed, where they're literally just doing timers, seeing how long it takes. Sure. So this is literally just like the time in microseconds, and then they're sampling it many times and averaging it, smooth, etc. Then even then smoothing it over multiple multiple calls to this, probably. Yeah. Okay. And then it's literally just threshold. So it's like if sends from config is greater than 0, then they use that thing, or they get the auto. Okay. Where threshold should be this is units of microseconds. Calculate threshold based off current baseline factor. Ah, here. Okay, I see what they're doing. So they're update baseline with smoothing. So here they're using the time it took and the ratio. That's confusing. Update baseline with smoothing if the surface is considered engaged. What is threshold? Threshold is baseline times ratio, where baseline is like an external number. Okay. Touch, auto, start. Sure. So like, okay. I mean, they are using really small numbers. All of these numbers are quite small, so this is like maybe like 10, maybe like 1, right? Touch, auto, start, v0. So they're like 2 or 10 are 2 options for baseline. And then they're multiplying baseline times the ratio, where ratio is from this thing. So one of these presets. So like 2, somewhere between 2 and 1. So they're like taking this thing as like, this might be like 4. Or somewhere between 2 and 4 if the threshold is 2, right? And it's engaged if the elapsed is greater than the threshold. Sure. So they're saying like the time might double. And they're saying like, I think I saw somewhere in here they were saying that it depends on like the wired and wireless are different because like the trace lengths are different and stuff. So all of that matters. But okay, so maybe the numbers that we're seeing of like 2 and 5 are like not unreasonable. Right? Given that we're seeing similar numbers in here, that's not crazy. So we should be able to touch the pin to the cup, press my finger on it, jump up to like 4 from like 1, 2. Yeah, so I guess that's kind of fine. So 1, 1, 1, 1, and then I put my finger on 2, 4, 3, 3, 3, 5. Yeah, okay, I mean that's not crazy. So I think it's kind of working. And so we should be able to just like hook this up to the LED. Right? So we should be able to be like, maybe we turn the LED on if engaged. So we just have to figure out how to check if engaged. So we just say like, so here we probably care about one of these times is easier. So we probably want like a timeout here. Timeout in microseconds, like 10 is plenty, right? So that fixes this. Then we say engage or like touched is if GPIO edge low time minus start saturating sub is greater than 3. And we probably want to do this like on average. So we probably actually want like, we probably want to like run this, 10 times, right? and we want to like start by setting this thing high, then like waiting for the value to be read as high, then flip back. Right, there's probably like some time it takes to charge, but we know that we can like wait for like 3 microseconds, right? That's plenty. So we can like do wait in nanoseconds. So this is like 10 microseconds, right? Should be fine. Then we wait, is it low to high or high to low that's fast? Uh Low to high is the longer one. If read value is no, the times here are confusing. We want all of our logs to come together. Hold on. Maybe it's high to low is the long one. Whoa, what the fuck is going on? What changed here? Hold on. What the fuck do we do? Oh. Oops. Oopsies. Okay, put this stuff down here. And let's actually, can we log all this shit before sleeping? No, it's fine. Okay. Zero, one, zero, one, zero, one. I guess it's kind of both. But the 0-1 is like a little bit longer. Sure. Sure. Doesn't really matter. Okay, so we set it high, wait for 10 microseconds, set it low, then do this like start to end thing. Then do this timeout thing. Okay. Then once we have this, we say time taken. If time taken is greater than 0, we say total time it plus equals time taken. Time taken is a saturating sub of the time to the edge low time and from start. Okay. We need total time here. And then we probably say like sample, like valid samples. Okay. This is probably U32 is probably fine. Okay. And then here we just say total time over valid samples. It's probably better to go the other way. So like engaged is if the total time is greater than like 2 times valid samples. Right? Yeah. Yeah. So if it's 2 microseconds, maybe 3 is a better line. 2.5 or something might be better, right? We might be able to tune this a little bit, but let's say 3 for now. Then can we just write down here? Engaged is a bool of engaged in enaged. Okay. And this should be a U32 and I guess int cast, and it'll crash if it's wrong, but it won't be. Enable true. Yeah, all of this kind of goes away, I guess, huh? Bool is not the right thing. I guess we'll just do this. We'll figure it out. Okay. So he's spamming engaged false. Put my finger on there. Nada. Nada, nada, nada. Okay, so this isn't working. Can we print the total time and valid samples? Uh-huh. Like, how have I fucked this up? We should probably look at the output, huh? Total time 0, valid samples 0, huh? That seems to be what we're seeing here. Okay, so what have we done wrong here? Probably need to set this before clearing the thing. That seems important. Still, oh. It still seems like it's valid samples 0 all the fucking time. I guess time taken could be 0. This is more like if GPIO edge load time is set, is how we get a valid sample here. Still valid samples 0 all the time. Does that mean that the timeout maybe is too low? 100? Why do I have 0 valid samples all the time? That seems bad. Because this valid samples, my finger's not engaged. But like either way, we should be getting a number, whether or not my finger is engaged. Maybe you're just making a joke. That seems likely, actually. Okay. Can we maybe breakpoint on our GPIO handler? Is this thing getting called? No. It's just not fucking happening. If I fucking touch the cup with the stick, though, it does. Very briefly. But then only a couple times. Interesting. Interesting. So what changed? Because I feel like... Okay, let's change this and just look at the value of the input pin. Okay, so let's look at this guy. Input val. Oh, he's probably just 0 all the time, huh? Which probably means that we have to wait for him to go high. If input is equal to 1, break. There we go, much better. There we go, much better. All right. There we go. So now input val is toggling off and on like we expect. Let's go back to logging the stuff we want to log. So let's stop this shit, stop this shit, and let's see what our samples are looking like. Let's go! Okay. Can we make it so that if we log everything at once, then we'll be able to see it? So we'll do this. Enaged. He's enaged. Okay. So we're seeing some falses. So we are seeing that when I put my finger on here, the numbers are going up. Like we're seeing like kind of like a constant 10, finger on. We're seeing like up to like, I don't know, higher. It's weird that it seems like less consistent. Like especially like sometimes it's dipping. Right? Like here it's actually going below, which seems bad. So here I just tap the wire. I guess we should show the picture, huh? Can you only present when valid samples are non-zero? Oh yeah. Good point. Okay. Nice. Okay, so maybe we try. Okay, so this is like showing like 10. So this is like average 1 microsecond. Click here. We are seeing like numbers bigger than 1. Put my whole fucking hand on here. I'm concerned about the dips that are happening here. Especially over so many samples. That seems like a problem. Um. Hmm. I wonder if we need to like do like a wait in between it like reading high. To like give shit time to figure itself out. I don't know. Well, okay. I don't know, man. This seems sketchy to me. Like the difference is not significant enough, I feel like, to be able to tell. It felt like way more consistent before. You know? Like it felt like we were consistently seeing like numbers that were way bigger. Can we say that as well? The numbers were like 5 before, were they not? So why are we getting like total time is time taken. We do the edge load time minus start. We put the start here after this thing is settled into being an output, driven high. We then clear the GPIO immediately and then wait to see if we're greater than timeout. This guy's set in the interrupt handler, okay? So everything seems kind of reasonable to me. All right. Well, let's just change the number here. So this is too high. So this should be like valid samples times 2/3 for 1.5. Maybe even like valid samples. Sorry, 3/2. I feel like even that's like not really consistent enough. But we are seeing this thing then pulse true, false, true, false. The fact that there's time here, it really makes me think we're supposed to be pulling this guy one way or the other. Like, I know that we turned the pull-ups off, but like, why did we do that? Because it feels like there's something floating that's not really supposed to be. Hi, why do you care about the time taken? If it's really fast and time to 0, you skip the sample. Um, uh, I care because that's supposedly how we're supposed to measure that the capacitance has changed. Is that we see some like noticeable difference in the time it takes for our input to match the output. If there's a capacitor that has charge built up, then like it will kind of hold the pin in one way or the other. Was kind of like the theory here, I think. I guess you're right. Maybe we shouldn't. Maybe we should just always have 10 samples. I wonder if that changes anything. So like consistently here, or maybe we should be measuring both on time and off time. Maybe we're measuring it the wrong way. Maybe it's the other way was more. Uh. Yeah, what were we fucking measuring before? We are always reading edge low. That's when the fucking timer hits. But maybe we should be reading edge high as well. Maybe we see it both ways. Let's do this. Comp time, combine. Like this, and then where are we setting the edge? Here we do another comp time, combine. A slice of pins that we're changing. Okay, and edge high as well. So we can do this as well. So I guess we do this on high, low to high as well. Sure. Sure. So now we should be measuring both low to high and high to low. I think. That's much more reliable. Right? So we're seeing like basically like 8, 9, 10, maybe 11, 12. Hold it. We're seeing like, 15 to 30, like 20, 25 or something. Okay. So here, can we, like, if I just write this as like 15 here, is that more reliable? So we have false, 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 press the button. Pretty close to reliable. We could smooth that a little bit. That's pretty sick. That's pretty sick. Okay. Right, so we'll just show it again with my finger and camera. Press, release, press, release. I think that's pretty reasonable. So I think we would need to add some like oopsies, software debouncing and stuff. But that looks like the concept does work. So now we can do so that we can write a YouTube title of using a measuring cup to turn on a light as a light switch. We just have to say that we will set the LED value to engaged here, and then we won't be lying for YouTube. Right? So now what we should be able to do is point this guy down, and we should see the light turn on when I touch the measuring cup. Right? So light off. Let's see if we can see it. Transition. Light on. Light on? I don't see the light on, to be honest. It's not working. It's not working. Why is life so hard? Oh, because I wasn't holding the fucking wire. Wait, I'm a dumbass. I'm a dumbass. The measuring cup was not connected. So I hold this wire here. Click. Off. On. Off. On. Can you guys see the fucking light in the... Maybe the wires are covering it. Let's go! You see that fucking like tiny LED by the USB? Oh, yeah. Oh. On. It's so... Like, I would love to like not cover that so much. There we go. On. Off. On. Off. Let's go! Let's fucking go, dude! Oh, that's pretty sick. Let's go! Cool. I feel like I don't really understand it still, really. But it's pretty fucking sick. Pretty sick. I'm pretty happy with that. On, off, on, off. Are you building a bomb? Yeah, I mean, I guess. No taking this to the airport. Cool. I think that's a success. So this means that if we put an electrically conductive surface in the controller, it should be able to, we should be able to use that maybe through with some filtering, to be able to tell if we can turn the gyro off. Sick. Right? Because again, like also our response time on this button is not important, right? We kind of only need this to be accurate within like, 50 milliseconds or something, which is like tons of time, right? Just to be like when I lift my hand off the controller, it like stops rotating. So I think this will work. Cool. All right. I think I'm going to call it there. Short stream today. Thanks for watching. If you like what you saw, we stream most days at around 12:30 Pacific time. I'm going to stop claiming that there's an end time that's valid, because I think that I say we usually stream till 4, but I think that it's usually not really till 4. But, we start at 12:30. That's pretty reliable. So, yeah, if you want to see more, swing back by tomorrow, 12:30 Pacific, which would be just under 2 hours ago. If you are watching live, VODs go up on the YouTube. There's a YouTube link in the Twitch description. Some VODs do not make it there, depending on if I think they are titleable and thumbnailable. If you want access to the remaining VODs, please consider supporting on Patreon, YouTube, and Twitch. This content will end when I run out of money, right? So making money means stream lives for longer. So if you want to see more and support the stream, those are your options. I think that's all the plugging I want to do. YouTube, peace out. Twitch, let's find someone to raid.